video, we're going to look at the concepts of the motion of physics that follow the understanding of position. And that is distance and displacement. Distance, you think, well, I know what distance is. Distance is, how far something goes. And that's exactly right. That's exactly right. But in physics, we're very careful to be very precise with our language. And we use words in a very specific and certain way. And distance and displacement are different concepts that are both related to initial and final position. So in order to measure distance, we need to get a length measurement, a measurement of the length, or a measurement of the change in position. And we're tempted to use the word distance to describe what we're measuring between the 2 points. And in some sense, it's okay to do that. But we just need to have in our mind that there is a clear and specific definition of distance that is different from just saying the distance between 2 points. So we try to specify that by saying distance traveled, but a lot of times we'll just get into a hurry and just say the distance. So in order to measure the length of something, you need a measuring thing. In this case, it's a tape measure. So I'm going to take this tape measure, I'm going to go down the hall here, and I'm going to get to a distance of 50 feet. So position 1 will be at 50 feet. So here, the measure of the space between where I am and where the camera is 50 feet. Now I'm at 10 feet. So back there, position 1 was 50 feet, position 2 is 10 feet. So we can calculate the change in my position from 50 to 10, and that gives us what is called a displacement of 40 feet. My initial position back there was 50 feet from the camera. My second position, or my final position, is 10 feet from the camera. So that gives us a displacement of 40 feet. Initial position, final position, the displacement is 40 feet. Now, that is not the same as the distance traveled. Why? Because what you don't know is that I walked back and forth across the hall many, many times. So the path that I traveled, the path that I actually traveled, is not the same as the displacement. The displacement was from there to there, but the distance I traveled was all over the place. And I end up at the same place, but the path I took was much, it would measure to be much more than 50 feet. Because I went back and forth and back and forth and back and forth. So the displacement is the shortest path and the actual difference between position 1 and position 2. But the distance traveled is the actual path that was taken to get from position 1 to position 2. Now, in a lot of cases, the distance traveled and the displacement are exactly the same. If you start with a ball in your hand here and you let it fall to the floor, the path that it travels is exactly a straight line, and therefore the distance and the displacement are exactly the same. But sometimes, in a lot of cases, the path traveled will not be a straight line, and in that case, the distance and the displacement are different measures. They're different measures, they're both length measures, they're both feet, but one is a measure of the curvy path, distance traveled, and the other is a measure of the straight line, displacement. Now, it's not terribly complicated, but it is terribly specific. And it is that specificity that sometimes causes students to get a little bit confused. Most problems, most physics problems, it's going to be one or the other. You're not going to be looking at displacement and distance. And so the confusion is slightly lessened. But the point is, distance and displacement are different, and they're different concepts, and you need to be able to differentiate between the two. So straight line. The straight line is the displacement. No matter what the path that was actually traveled is. Now here's kind of the fun part. If you're on a merry-go-round and you go around the circle once, you can calculate the distance traveled as the circumference of the circle. The displacement, though, if you start at one point and you go around and you come back to the same place, there is no displacement. So even if you were on a racetrack, perhaps you're at the Indy 500, and the track is 2.50 miles around. If you go from the starting line 2.5 miles back to the starting line, the distance traveled is 2.5 miles. But the displacement is 0. Now when we get to the next concept, which is an examination of the change in displacement / change in distance, the rate at which it changes, speed and velocity, they're directly related to distance and displacement. Speed goes with distance traveled, velocity goes with displacement. So that's it. That's it for distance and displacement. So there to there is the displacement, back and forth across the hall, down the other hall, and back. That is distance traveled. Thanks for watching. Hope you enjoyed the video. You know what to do. Like button, comments, share, subscribe. See you in the next episode.